Hello everyone, and welcome back to a new episode of EXAPUNKS. It's just me this time. Rose only had time for one episode. If I had to guess, we won't see her again before I'm done with the game, simply because I've been playing through it pretty quickly. And I think we're getting close to the end, from what I understand. Someone mentioned on the Reddit that, like, around here, maybe, it was 2/3 of the way through? I'm not sure. We'll just let it end when it ends, but anyway, in the meantime, that's why there's no Rose. So, hope you guys enjoyed that special treat. Let's move on to this. I don't remember seeing this, like, when at the end of the episode, I thought there were only 2 puzzles, and there are 3 now. I'm not sure which one is new. I think it's this one, but okay. Find new hosts for Ember 2 by exploring and mapping a dataphone network. Wait. This is the one I did. Why is it lit up? Why do you... Did we not finish running? We definitely did. Excuse me? Did I make the mistake of... I had this edited version I wanted to try. Did I never actually let it finish running? Or maybe I, like... Because I closed the window with... I don't know. I don't understand what happened. Okay, so what happened to this poor guy? What optimization had we tried? Like, I didn't make a copy of the solution because I figured it didn't matter. But I remember we optimized it a fair bit, so the solutions should have counted. We did all this stuff. And we had test, yeah. This test MRD should have succeeded, right? Oh, it did. No. Since it did not succeed, that means we are going to begin the paste loop, right? No, wait, but it went back. So is this like a race condition kind of thing, where, like, the solution worked a minute ago and it doesn't work now just because it's unpredictable? If you have something test MRD the same time that someone else, like, this guy is sending. So apparently we do need to have a no-op in here. Wait, there is one, though. Or wait, no. I guess it needs to be here? No, hang on, what am I, an idiot? It goes here. Huh. Alright, so that should run successfully? No, that also crashes, so I'm incorrect. What is going on? We've dialed a thing. We spawned off an enter process. We closed the thing. Now, at this time, this guy is copying stuff. He's broadcasting a message. So when we test MRD, it should be, yeah, okay. There should have been a message ready. I don't understand. This guy is broadcasting right now, and so if we test MRD, is he in local mode? No, they're both global. Is another no-op needed? Why? That doesn't fix it either, so something is, like, way out of whack with these guys. What in the heck could be going on? Test MRD is returning 0. Even though we can see right here, there's a message, like, ready to go. You're in the middle of copying to M. Alright, I don't get it. I'm gonna just... We solved this one. I don't know why it thinks we didn't and why our solution doesn't work, but I'm not gonna go back to it unless there's some need to. I was just thinking that, like, I don't know. Nothing, I guess. Just, I don't know why that's messed up. Destroy the nuclear centrifuges secretly operated by Last Stop. Wow, they have real centrifuges. Let me see if I understood that correctly. Last Stop, the convenience store chain, is actually a front for a cult. They believe the world isn't real and are in the process of creating a nuclear weapon in order to escape it. And now you're going to attempt to take care of it yourself instead of alerting the authorities like a normal person. Yeah, that sounds right. How heroic of you. Well, go on, have your fun. Or maybe you said your turn, I might have misread that. So here we are back in the Last Stop network, but instead of messing with their peanuts, we're messing with their nukes. So what's the deal here? An array of 5 zippy-type gas centrifuges, ZGC0 through 4, are connected in a cascade configuration. Read each of the ZGCX registers and determine which centrifuge currently has the highest pressure. Then disable that centrifuge's regulator by writing a value of 0 to its power register. Repeat this process until all 5 registers have been disabled. Interesting. It seems like the kind of thing that you would do with a macro that, like, has a parameter, which is the number of the thing. And you don't need these guys to coordinate with each other, really. You just have to arrange that. So, like, I don't know what. Let's go read what the temperature or the numbers are right now. Okay. So let's link 800, link 799. Oh my god. No, I do not wish to restart this time. I told you, like, 4 in the morning is when I want you to restart. I don't need a notification about it right now. It knows. It's like, yeah, I'll wait till 4 in the morning. But it still just wanted to let me know. Thanks. All right, so here we are. And what I want to do is repeat 5... hang on. Make a file to store the results in. Repeat 5 times a copy from hash ZGC of the number, the iteration number. Just so I can see what they all are and, like, make a plan. Oh, whoops. Into F, please. ZGC, not ZGT. Okay, so these values are all, like, in the neighborhood of 200, right? Like, between 1 and 200. And you could imagine, since we want to shut down the lowest one first, or the highest one first, you could imagine waiting for a number of cycles equal to 200 minus the pressure number, right? And then just shutting that thing off, and that'll achieve the ordering you want. Now, that's sort of, like, inconvenient because you're doing all this waiting for no reason. What's with these 2 files? Are these, like, their recipes? Yeah. Huh. Actually, like, they don't look like recipes, they look like dates. Okay, obviously it doesn't matter, just puzzled. And you'd have to like make sure to account for how many, how long it takes when the EXO is spawned and how long it has to walk, right? The lowest number. Oh, you could cancel those out by starting at 5 and counting down at spawn EXOs. Yeah. So you could send 5 this way first, and they'd all arrive at the same time, right? And then they could just wait for the delta between this and the largest of them. Now, it's a little inconvenient that I can't tell what the largest is. Like here, it looks like 200. And in fact, if we had like a range of what the pressure numbers are, like if someone told me they're between 1 and 200, then it would be simpler, right? I guess well, so that would be a way to optimize for speed, right? Is to minimize the amount of time you spend waiting around. You could also like just come up with some sort of way for them to actually sort themselves so they don't need to wait. That is probably the best cycle count, right? Because it's not that difficult to sort some things. But actually it seems like rather hard to orchestrate all of this stuff, whereas just waiting is fine. So what I was thinking is I could have I could have one bot, one EXA, that reads all 5 of these values first ahead of time to figure out their max, and then again to figure out their min. And you know, we'd probably need actually 2 bots to do that. I guess you could actually just have 2 separate EXAs. Anyway, and then some single EXA with both of those values in its registers would replicate 4 times to read all of the power readings and compute how long it should wait based on those. That seems pretty good. And the only improvement I could see would be to sample all of these, somehow sort them, figure out which one should be first, and like orchestrate all of that. Seems extremely difficult. Compared to doing this like approach of just waiting for a reasonable amount of time. So I think I'm going to try the waiting for a reasonable amount of time business, but I will try optimizing it because it sounds like fun. So what we're going to do is copy this into X, test whether... Ooh. X is not a convenient register, is it? Okay, so I just won't do this copy. I'll just test whether this is greater than X. Mark min of, no, not here, here. Min of 0, 1, let's say. I'll have down there. If it is greater, we want to skip the copy. F jump to this. Otherwise, copy into X. So this guy is going to be our max, right? And And he has computed 186 as being the largest in any of these registers, which sounded about right to me. Fine. Meanwhile, another bot will do the same thing, but computing a min. Like so. And then min will copy from M into T, and then it will fork a bunch of times, while this guy just copies X to M. So he'll broadcast the max, and we'll have the max in T and the min in X, which is a little backwards. It would be more convenient if we had them the other way around, which we could do by having this bot send the message first. But I think actually it matters a tiny bit which one happens, because this guy moves first. Oh, I guess actually it's about... So imagine that each of them had to do the same number of swaps for some reason, right? Then the one who moves first should be the one who writes, because it's slightly slower to write to M than it is to read from M. So MX should write, and like, I don't know. I guess I could just change these and the order of them and relabel them, and then it would be fine. So this guy's now min, and this guy's now max. Little aesthetic things like this are not that important. But now, there's a 0 here. Yeah. So we actually need to do a little bit less, actually. Repeat just 4 times this process. And the first time, just copy ZGC 0 into X. I guess we could be a bit faster if we didn't do this with a macro. We can repeat 3 times, I guess. Copy, no. Let's test whether ZGC 0 is greater than ZGC 1. And if so, we'll jump to begin, I guess, I don't know. This is not actually any... I was trying to figure out a way to just write a single value and not use the X register. But it's actually difficult, because you could just you could do here, like what you would do is you'd say copy from ZGC 0 into X, and then here you would overwrite it, copy from ZGC 1 to X, right? And that's all fine. But that's not actually any better from just starting by copying into X. So I guess we'll do it this way. We'll copy this into X, and then, starting with 1, we'll do all this stuff to compute the min. And this guy's going to do the same thing with max. Does that come out better? Yeah, they've each computed numbers within the domain. Oh, one of them's... now they're both... Since I copied the code, they're both copying. Oh my god, they both have labels named min. The worst. Whatever. Who cares? I've decided I no longer care about aesthetics. This is the one who finishes first, so he should be writing. And he has X. And this one should copy from M to T. Now, this guy knows what order everything should be done in, and he knows the range. So we need to do some calculations here, in fact. What is the calculation exactly? Okay, so we've run this whole thing. And we now know that every number lies between 186 and 102. So, assuming that everyone arrives at their respective power markers at the right time, oh geez, we're gonna actually have to have 5 copies of everything because we can't just have a shared loop, a shared code space that they have different values for, because there's a different register for each of them. The worst. So anyway, you get a number and you look at it, and I don't need the min at all, do I? You just subtract that number from the max, and that's how many cycles you need to wait. And that's all. The min was completely pointless. Alright, well, get out of here then. I guess I'll call these max since there's just one. I mean, to be called min is pretty stupid. Okay, so we've computed the max. And it's in X. And we have... Oh, even just waiting for a particular amount of time is hard because we don't do like a sleep operation like we did in Shenzhen IO, for example. I mean, you can write a loop, of course, that just counts down. But like then you're waiting 3 times X instead of just X, which kind of stinks, right? But I guess that's the best you can really do. Okay, well, you got me. So we will repeat 4 times. 5 times? 4 is fine, I guess. No, I guess we need 5, right? Because... we want 5 copies of the code. I guess we unroll the first copy because or the last copy, I guess, is what we unroll because we don't want to replicate, we just want to jump. Or do nothing, really. Although, actually, to keep things synced up, we might as well have a replicate, right? We're going to need the last one to stall a bit anyway, to make sure that he times correctly with the others. So yeah, I guess we will just do 5 copies, do a useless replicate, and then throw the guy away. So let's repeat 5 times the following. Subtract from X, the maximum, the value in hash of ZGC of starting at 4 and counting down. So remember, we want the furthest one to start first because it has the furthest to walk. Oh, hang on. Rep 2. Not of 0 to 1. So I guess this would also be 4 to minus 1. So we need to now here mark this saying, so if you are, this is backwards. If you are not the bot responsible for 4, please skip this step. And if you get to this step, then you must be the bot responsible for 4. And then we're going to jump to wait or something, right? And wait is going to be the code responsible for doing all the math and turning off, actually walking over here and turning things off. They'll all share that code. Oh, they can't even share that code because the register numbers are different. Jesus Christ. There's no size limit, thank God. It says in this task your size... Oh. My size is NA because my code doesn't compile. I'm in the middle of a weird macro. So if I say end, it'll tell me something is still wrong. Why? Oh, I didn't say where to store the result. Put it in X, please. My code is 40. Okay. God, this is awful. Alright, well, let's keep going in this direction and see just how bad it gets. So in wait, we actually need to do a bit more. We need to copy the number that we're working with into T, so we know how many steps to take. And then let's link -1 to get us here. Again, link 798 to get us to this entry. And then we're going to need to do a loop. Ah, we can put that loop. Well, can we though? This shit is all being repeated. Oh, I don't need to duplicate because these are all the same register number. They're all just power. Okay, I was worrying about nothing. Fine. So what that means is all of this shit can go in wait, which is shared by everyone. Right, we just have to have X be how long you want to wait, T be how many steps you want to take once you're here. And then you can do stuff to power. Okay, thank goodness. So let's see how this looks. Do they all get to the right place? They're all dying off. I think they're getting there at the right time, but there was some time. There's actually, like, they ran out of space in this room, I think. And so someone might have been stalled trying to replicate, but unable to. Yeah, there was one turn. A couple turns, in fact, where they're unable to replicate. So it would be better to link -1 and have that be copied. Have them all use the same, just to get them out of this room as fast as possible. There. Yeah. And now they can all get on their way after stopping here to do a little math. And so what we want to do is, now we're here. Mark. I assume these are all like link 798, but it doesn't say. I guess I'll try. Let's just say link 800. Oh, there's a compass. Okay, right. So this compass is here as a default for when a thing is not labeled. Okay. Got it. So what we want to do is mark here walk or something, right? And what we want to do is test oh. The problem is that walking doesn't just take one cycle, right? Since we're doing it in a loop, it's like a test and then a conditional. It takes like 3 cycles to walk, and so we need the 3 x's to be off sync by 3, right? When we create them. Which I guess is simple. We can just say op, no op, no op. I guess we don't need this link -1 to be duplicated anymore because we're going so slowly. How about this? Hang on, they're no hopping before they leave. That's no good at all. Let's put it here. No, that's before the jump. Wait, that doesn't keep them desynced at all, does it? What am I doing? Am I like losing my mind? How do I get them to be 3 off sync from each other? Putting no ops in here doesn't help, right? I feel like it should. If they all go through the same number of no ops, it doesn't help. Of course. Does it? No, it creates a... But this isn't going through the same number of no ops, right? If you're not... Yeah, it is. I need to put the no ops before the replicate. No, hang on. The highest numbered ones should be the ones who wait the fewest times, right? And this accomplishes that, I think, because the one labeled 4, I can actually do better, I guess, by putting it here. So the guy labeled 4, let's say, will not have any no ops. He'll do these 3 things and jump to wait. But the one who's not 4 will jump to here and then do 2 no ops and then go like do this whole thing again. And if he wasn't 3 either, he'll have 2 more no ops, I think. Yeah, look at them. They're going in groups of 3. That's great. Which I think is what I want. I guess I should have tried to prove that before I implemented it, but I think it's right. Okay. So now we need to some number of times and make sure this takes exactly 3 iterations per walk that you're taking, right? Per step. Or so that each additional step costs you 3 more. Maybe the first one takes 2 and the second takes 5. That's okay too. So I think we just wanted to F jump to... let's not call this weight, but like spread. We're not actually ready to wait yet. T jump to wait, I guess. Or F jump. Otherwise, link 800 and then jump to walk. Right? Sorry, I was just looking at this guy's head because I saw his like something out of the corner of my eye changed when I fixed this error, and I was like, wait, what happened? Is there a thing here to tell you that this is the one who doesn't compile? And I remembered, yes, we discovered earlier that if it doesn't compile, it has some like shorter head. Anyway, so let's try this. Oh, look at them. They're lining up so beautifully. Oh, it's gorgeous. Did I make too many copies though? What do you have in your head here? You should halt. Although actually, I think he's just gonna walk off the edge of a cliff and like, that's fine. Nope, everything is wrong. What in the world happened here? Everyone was all synced up and then badness occurred. Why? What does this guy get in his head? So he's MX. He has 0 and 4, which is like completely useless. I think. Or no, 0 is... Wait, this guy has 186? This guy has 10? Oh, maybe he wasn't done doing the subtraction? Yeah, I think that's what it was. This guy has a 0 and a 4. This guy has a 5? Oh my god, I forgot to subtract in the walk step. Okay, so apparently we need one more. There's not any way we could arrange... We can't, like, take a link before doing a test, right? Because there will be at least one bot who should take no links. Therefore, we must do a test before the first link. And we must store a 0. I was thinking, like, could I store n minus 1 instead of n into t? But, like, no. Okay, so it looks like we need one more no up in here. We should have plenty of space. And, oh, The guy who is done needs to halt. He does not have any useful values. Wait, did I get it wrong? Maybe he was useful. No, I count enough bots. They're all at F jump weight right now, right? But they have these like gigantic T values. Six? Did I forget a minus somewhere? Yes. Wait. No, this is what I meant to do. Oh. No, it isn't. I meant a minus. Okay. So this guy has a T of 4. 1, 2, 3, 4. This is correct. And you have a T of 3. This is all looking very good. They're all at the T jump step, and they all have a T of 0. Great. And they all wink out of existence at the same time, so they were definitely synced. Good, we got them to where we want to be. And now what we need to do is just copy X into T. And then here, I guess? No. Well, we'll say to jump to the prep step. And the prep step is to copy X into T. And then we'll begin the waiting. Where we... I guess we can do... I don't want to have like an F jump and then a jump here, right? Because that makes each cycle of the loop longer. Ah, and so instead of copying X, we can add I of X and 1 to T. Now, when we start our loop by sub I T1, storing it to T, the lowest value will be a 0. And we can T jump back to wait. The shortest possible loop here, I think. It could be a bit shorter if you could like put the first jump before the, I don't know. And then we'll just copy 0 to power, right? So what happens as a result of all this? They all get there and they all decide, yep, this is where I belong. Who has the lowest X? Someone should have an X of 1 now, right? Or 0? The first guy. He's now adding 1. And immediately subtracting 1. And he's determined, oh, I should turn off number 5 first. And then die. Now the other guys have a lot of waiting to do. This thing stopped wobbling. The goal... Oh. No, we failed at disabling the regulators in the correct order. Why? Am I crazy? It should be. Subtract from the largest value you saw the one that you have. The guy who read 0 traversed 0 links. I'm gonna make another exit here just to like copy all these values into a file again so I can like double check. So this guy, the order they should have been shut down in was 4. That's this one, 4. We're 0 indexed here. 4, 3, 2, 0, 1. Right? Let's wait till they're all in line and see if they have correct. You have a wait time of 0. You have a wait time of 10, 27, 28, and 84. This is what I intended to occur. They all have accurate wait times. So something must have gone wrong in the waiting loop that I did not expect. So, okay, well there's one like tiny little optimization I can make that I noticed while I was looking at all this. I guess we can delete this guy. Is that we are T-jumping here. T-jumping to wait is fine. There's some other F-jump. This walk loop doesn't look right to me. We're jumping back to walk and then F-jumping to prep. Whereas we could just fall through by doing a T-jump backward to, instead of prep, call it step. Help, what did I do wrong already? So we get to walk, right? And then we have to jump to prep, which is fine. We need another mark here, step. And we just F jump to step instead, but we leave the prep stuff alone. This way, this one extra F jump is only executed once. Oh, this would be a T jump though? Oh, no, that isn't correct because I actually needed every iteration of the loop to take the same amount of time. They're out of sync this way, right? Well, let's see. Maybe they actually get synced up. Like, now they're all in position, and so they should all be at the same point in their program, right? But they're clearly not. Right? One of them's copying to power. Yeah, they're all off by 1 this way. Okay, so that optimization was short-sighted because I don't need this to go as fast as possible. I need it to be organized. So get rid of this whole step business. And just jump back to walk. Okay. But, so my question is, like, what is wrong with the post-prep steps? Do the things get shut down in the right order? And it just, like, I don't know. Let's see. No, that one went out first. That's correct. And so all this stuff is wobbling the way it should be. And they still have correctly ordered everything, right? This guy should be the first to go. But this like repowered itself or something. But this says 0, and that's correct, right? Oh. I misunderstood the instructions. I assumed repeat until all 5. So what I had assumed was that the pressures would be constant. And that shutting them down in the right order would be something that you could compute ahead of time. But repeat this process is sort of implying, although not strictly saying, that the pressure numbers can change. When you shut down number 5, apparently, something other than number 4 became the top offender, right? So we need instead to 5 times read all of the registers, find the highest one, and go get it. I see. Well, this was a cool program that I wrote. I think it did a neat job of solving constraints that were not the right ones. You know, an expert lesson in how software works in the real world, right? You spend months solving the wrong problem, and someone's like, that's not really what I wanted. Oh well. I'm not going to finish this episode because I suspect we have a lot of rewriting to do. But what I will do is we'll call this synced, and so I have it around because I think it was a cool program, and we'll just make a new one named iterative. And we'll probably, in fact, copy quite a bit of the code from there. Yeah. It's actually a little bit tricky to even calculate the max of all these so well. Because you're using the X register to like store the max, and you can't use the T register to store which number it was, right? But what I think you would do well to do is create a file to carry around, and just every time you detect a new winner, you write the winner's index to the file, and its values live in X. And then when you're done, you just look at the last entry in the file, and that's where you go. Okay, something like that. So hopefully we can get through this one pretty quickly in the next episode. Thanks for watching, and I'll see you next time.